transforming large markets. And every day we work closely with our cloud partners to help bring new AIs to life. We collaborate on the systems, the physical and software infrastructure, the AI frameworks, and AI applications, both for their internal cloud services and their cloud customers. And it's a platform that's continuously growing. It is estimated that the cloud server market install base is 20 million servers, and analysts project that this number will grow to 35 million by 2025. Driving that growth is the consumer internet, the apps, the websites, the services that each of us use every day and is built on the cloud. Not surprisingly, 100% of the consumer internet applications will be adopting AI. From Meta to PayPal, Pinterest, Snap, and Twitter, AI is being developed everywhere to process every engagement, every product, every recommendation to deliver great customer experiences. As a result, AI recommenders are becoming the engine of e-commerce, with over $7 trillion worth of sales projected by 2025. And these are just some of the customers using NVIDIA AI today. NVIDIA's growth in hyperscale computing is continuing as more companies and developers find new ways of adopting AI for their applications, and the introduction of new GPU architectures turbocharges that adoption. New GPUs do this in three ways. First, by reducing the time to train, we speed up the productivity of AI developers, helping them deploy more AI in the cloud and drive faster growth for AI infrastructure. Second, by improving the scalability of our architecture, we expand the scale and size of AI supercomputers to help our largest customers, as well as NVIDIA ourselves, to build the next generation of AI infrastructure and push the limits of what AI can achieve. And third, by improving AI inference, the production use case of AI, we widen the aperture to allow even larger and more powerful AIs to be deployed into production. Just as we saw a 3x revenue growth from the launch of the NVIDIA V100 to the A100 GPU, so too will the Hopper H100 enable a new wave of AI models and applications. Hopper is the new engine for AI infrastructure and will be the platform for innovation for large language models, recommender systems, and the complex digital twins in the cloud. To advance AI, it is important to understand the trends in AI. Over the past few years, a new type of neural network has emerged. Invented by Google, the transformer has become the dominant building block for neural networks. Built on the idea of attention, transformers help AI understand which parts of a sentence, an image, or disparate data points are relevant to each other. And unlike CNNs, which typically only look at immediate neighboring relationships, transformers are designed to train on the more distant relationships, which is important for applications like natural language processing. And transformers are transforming AI. 70% of the AI papers published in the last 2 years incorporate transformers into their work. Transformers are also the building blocks of the world's largest neural networks for large language models, like OpenAI's GPT-3 and NVIDIA's own Megatron Turing NLG 530B. This neural network has 530 billion parameters trained on the corpus of the internet to build intelligent chatbots and other intelligent language applications. Hopper, with its new transformer engine, is explicitly designed to accelerate these transformers. It can train GPT-3 6 times faster than A100, reducing the time to train from 5 days down to just 11 hours. And it gives the latest mixture of expert transformer models from Google a 9x boost, reducing time to train from a week to less than a day. Hopper's innovations don't just benefit training. When deploying these models for inference, Hopper delivers a 30x higher throughput compared to the A100. And Hopper's ability to accelerate transformers will not only help bring new AIs to market, but will turbocharge AI productivity, and as a result, the demand for AI infrastructure in the cloud. There is a second, equally important AI use case that is taking shape in the cloud: AI-based recommender systems. Recommender systems are the commercial engine of the internet. Hyperscalers and the cloud service providers use recommender systems to connect literally trillions of items with the billions of consumers. Even the simplest search query today involves a complex recommender system that attempts, on the first try and only in a few milliseconds, to connect you with the right product, article, tweet, or advertisement. NVIDIA Merlin is an open source framework for building large-scale deep learning recommender systems. NVIDIA Merlin's NVTabular library can accelerate feature engineering and pre-processing to manipulate the many terabytes of unstructured data sets into AI tensors that can be operated on by an AI. In addition, Merlin supports distributed training with model parallel embedding tables and data parallel neural networks running across multiple GPUs for these giant models. Snap used NVIDIA GPUs in Merlin software to achieve a 50% increase in the cost efficiency and an improvement in serving latency by 2x for their content delivery. Training and operating recommenders with NVIDIA GPUs saves money, enables smarter, more intelligent consumer interactions, and activates the $7 trillion worth of e-commerce coming to the cloud. Inference. Once you've trained an AI model, you need to deploy it. 5 years ago, AI could still be run on legacy CPUs within the hyperscale data center. The overall amount of AI workload was small enough, and these models simple enough, that one can use the millions of existing CPU servers to deploy AI. That's not true today. As AI has gotten smarter, AI models have gotten larger and more complicated. CPUs simply cannot meet the real-time inference requirements of modern AI. Furthermore, as AI has become an increasingly larger part of the cloud workload, optimizing infrastructure for the AI throughput of the data center matters. We have seen a rapid shift to GPUs as a result, starting with the NVIDIA P4 GPU in 2016, the T4 GPU in 2018, and now with our Ampere-based A2, A10, and A30 GPUs, we've experienced a 9x growth in our inference revenue. We invested heavily in software for inference. A software platform for inference needs to handle all the different types of models used across the company to deliver inference in real time, while maximizing the throughput of an infrastructure, as well as handling the increasing complexity of AI models. To tackle these challenges, we built the open AI inferencing software solution called Triton. Unlike the training frameworks, Triton is designed exclusively for AI inference. It is an open source framework supporting every AI model running on CPUs and GPUs, and has become the de facto framework for AI inference across the cloud and on on-prem deployments. Last year, we announced Grace Hopper, the ideal processor for giant scale AI and HPC. This year, we've announced the new Grace CPU Superchip, the world's fastest, most efficient CPU for the data center. For markets where CPU performance is paramount, Grace shines. And as AI models continue to get bigger and our GPUs get even faster, CPU performance plays an important role in managing the execution as well as the pre- and post-processing of data for AI operations. The Grace CPU Superchip is designed to be the CPU for AI infrastructure. Its performance and efficiency will allow GPUs to train faster and larger AI models without ever letting the CPU get in the way. Furthermore, Grace's configurability for new CPU-GPU system configurations allows us to optimize AI infrastructure for different workloads, leveraging both existing PCIe-attached GPUs and GPUs attached with the new NVLink chip-to-chip interconnect. The Grace CPU Superchip is, of course, an amazing CPU all by itself, and we're seeing strong interest in scientific computing, data analytics, hyperscale computing applications, where absolute performance, energy efficiency, data center density matter for those CPU applications. For NVIDIA, we see the data center as the new canvas of innovation. With every generation of AI, we innovate, unconstrained, studying all aspects of how AI operates inside the data center, knocking down barriers and inventing new technologies and products to optimize that infrastructure. With new kind of compute-rich servers based on our Hopper H100 GPUs and our HGX GPU baseboard products, optimizing communication with Bluefield 3, Spectrum 4, Quantum 2, and even integrating networking and GPUs into single products like our converged accelerators, we have added compute to the network itself, offloading teraflops of computation from the compute nodes and saving gigabytes of network traffic. This year, we're even taking it a step further by taking NVLink, previously used to connect GPUs inside the server, and now unleashing it into the data center itself, scaling interconnect beyond the server with NVLink switch systems. With Grace, we can broaden that opportunity to build novel CPU-GPU system designs for the variety of AI workloads. And of course, working closely with our hyperscale partners, NVIDIA is inventing the data center of the future together. Of course, now that we've opened NVLink C2C, our chip-to-chip interconnect, we are open for business for custom IP integration, which brings new custom silicon opportunities with NVIDIA technology to the cloud. The available market opportunity has expanded, and we've gone beyond the GPU and are now a 3-chip company. The new data center is redefining the 9 million hyperscale servers deployed each year, and this opportunity opens up a $150 billion market for NVIDIA in the hyperscale, and with just the infrastructure opportunity alone. NVIDIA is the only AI company that works with every other AI company, and we are at the center of the AI ecosystem, working with AI companies to bring AI to the cloud, enabling new AI applications, and accelerate innovation across industries powered by NVIDIA. Thank you, and I'll now turn it over to Ali Khani on automotive.